So I define a situation where, in epidemics, where there is a silent partner, a viral silent partner, when there is a virus which is unidentified and can cause severe disease. So there's a new unidentified pathogen, VX. There's also a known pathogen, which I call V, which causes a similar yet milder disease than this VX. So they can be confused. This V virus, which is known, also spreads faster than VX. So VX is more lethal and V is more transmissible. V and VX coincide in time. So the wave of V coincides, overlaps with the wave of VX in some location. It is important condition that the patient management, so the decision where to place patients which come to the hospital with, for example, pneumonia, let's say that these viruses cause pneumonia, will be based on two things. One is the V positivity status. So for some reason, the hospital decides that all V positive patients must be put in a V ward, what I call a V ward. So this is an isolation ward for V patients. For example, the hospital believes that, for any reason, believes that V is a highly dangerous virus. It's not, but that's what they believe. So they put all the V plus patients in the V ward. However, they also put in the V ward people who have either not yet tested positive and have very severe pneumonia. So these people, they're suspected cases because they were in contact with someone who has V, a confirmed V case, and they also developed severe pneumonia. So we can assume, even without a positive test, because sometimes for whatever reason you won't have a positive test, and that's legitimate, that happens. Severe pneumonia cases, even though they have not yet tested positive for V, they suspect they are V positive and they put them together with the V positive by molecular testing. What happens in the hospital? Now, if the wave of V does not overlap in time with the wave of VX, first, since V doesn't cause a lot of disease anyway, it doesn't cause very severe pneumonia anyway, then most people infected with V will stay in the community and only a few will come to the hospital. The hospital will not become full of patients, and these V patients will remain in the ward and there will be no problem. So it may be unnecessary to isolate them, but nothing bad happens. Now, a recipe for catastrophe is that when V and VX overlap, VX causes severe disease. It sends people to the hospital. Now, very soon afterwards, or even at the same time, other people are identified as V+. These people don't have very severe pneumonia, but they do have pneumonia and they are V positive, so they're put in the V ward. Some people may be co-infected, so they have both V and VX. Now, these VVX patients are placed naturally together with the V patients because they are in fact V positive, so they should be in the V ward. Other patients which don't have V but have VX and developed severe pneumonia, these are also going to go into this ward. Now, as you see, it's not necessary because even if you have VVX, that's enough, so they can come from the community. But in some cases, it could be that the policy would be that if you have severe pneumonia and you've been around people that have V, and everyone had V, so they send you just in case. Okay, so you bring in this VX. Now, people who are negative and don't have severe pneumonia, maybe people that didn't even come for, they're either sent home, or if they came for something else, they're sent to regular wards or departments. Now, this has a disastrous potential. If you have only V, there's no problem. 100% of the patients are positive for V by PCR, and there's no other nasty pathogen around, so they may have pneumonia, aspiration pneumonia. They just developed a bad reaction without any pathogen, specific pathogen causing it, right? So if if someone comes and they have aspiration pneumonia, no pathogen responsible, these negatives, they will become positive. Is, as we said before, highly infectious. This is not a problem, but this raises the point, which would be critical, that once in the V ward, people transmit viruses between them. So it's known that in hospital-acquired infections, for example, these V wards are not one room per person, they're wards, right? So these are like beds. Let's say you have 16 beds in a ward. So you have a big space and you have curtains and everything, and the nurses are super, how do you call it? Careful. But still, if it's an infectious disease, it's likely going to transmit. When there's only V, it's fine. But when you add VX, it's a disaster. Let's say 90% of these people, even more, are positive just for V by PCR. And one of them, he has VX, she has VX. So it's either an NVX, which is negative for V and positive for VX, or VVX, like we saw before, which is a double infection. Now the hospital suspects it's a V case because it's a really serious pneumonia, and they believe that V causes really serious pneumonia. They don't really see it that much. But here, for example, they do see it. And even though this person is negative initially, soon this patient is going to become a VVX. The V is super contagious, right? So this guy is going to immediately get V. So he's going to be V positive. So now the doctors see this thing and they say, well, this guy, as we suspected, had V. Okay. We don't know about the VX. VX is the silent partner. Now VX is also transmitted slowly, maybe. Maybe V is like 3 times more infectious, 4 times, 5 times, 10 times more infectious. But VX is also infectious to an extent. Maybe it infects every 1 week. It infects a person, can infect another person. Right? It's actually maintaining itself around R0 of 1, so it's near extinction. But it still infects. And like once per week could give it's a low infection rate. V can infect, for example, 10 times per week. Now we have a bunch, like we have now 2 VVX infections. VX is really nasty, and this guy dies. This woman dies. This patient dies. But he already infected, right? And this guy infects this, and he became infected, and this guy became infected. And then this guy died, but this guy was already infected. And he, for example, infected 2 people here. I don't know why I gave them 2. This guy is still infectious. This guy got infected. Now this guy infects this, and this infects this. So this was a hard week. I don't know why I chose these numbers, but now we have 100% of the patient population positive for V, as expected, as the hospital expects. All these people, now a bunch of people here are very sick, and they are positive for V. So the doctors think, okay, yeah, we're dealing with a massive outbreak of V. It's difficult to think that just a week before, the Vs that came in were not that sick. Now this guy dies. You have more and more VV and VVX infections. Now you're beginning to have, eventually, the VX causes more severe disease. These people are going to stay there. And the other people are going to come in, and until they're clear of V, they're not released from this department, which really puts them together with a shark, right? So what you have is that, as expected, everyone has V, so the doctors have no specific reason to, or no particular reason to be asking themselves what's going on. Are we dealing with another thing? Because this VX behaves exactly as they think that V should behave. Now, when V doesn't behave that way, because there is no VX, they're lucky. Or they think, well, we treated really well this time, or this time the demographics, or this time whatever. But the thing is that was just the silent partner was not there. So V just behaved like V, which is not that bad. When VX is around and it manages to penetrate this, it creates a hotbed for VX. It starts infecting in this thing, and over time it's going to explode, basically. I mean, as you have more and more VX, there's still a lot of V. Everyone's defined as V, but you have an increasing death rate. right? So you have more deaths. So initially you had a V department, which was kind of okay. I mean, people were dying because people die in the hospital, but not a lot. And then when VX came in, it kind of like still was fine, and then unless you're aware of the possibility that there is a silent partner, because it's really unintuitive, right? I mean, we with our highly sophisticated machines are looking at everything, and this guy is just passing underneath our noses, and that doesn't make any sense. There are signs. I suggest that there are signs that there is a silent partner situation at hand, that a silent partner is contributing to the death of some outbreak. It can be very difficult to notice it at the local level, as I've shown before, because you don't see it in the population. You just see it in a really, if it was happening in the population, you say to yourself, then people would be dying left and right, and they're not. Because in the hospital they're dying left and right, but that's because they have VX, which is actually kind of rare in the community. And when people develop VX, they go to the hospital. So almost everyone that has VX is in the hospital, right? So the system works in terms of symptoms. You put the system kind of pushes these people into the hospital, but the hospital is not aware of VX. At the local level, it's really unintuitive or far-fetched, I would say, to assume something like that, because they're telling me that V does this, right? So V does this. So why would I why would I like to, how would I look for a VX? Right? I don't even know how to look for it. So I can test for viruses which I know, and apparently I'm not getting, consistent results with that. And there is no virus that I don't know about, because why would there be? That would be just a weird coincidence. What's the probability? I don't know if it's low or not. It depends on how many viruses emerge per month per location, and it's probably low, really low. But the silent partner has an effect which can be measured when you compare various facilities. VX causes the severe disease. V causes similar symptoms but mild. When V and VX coincide, you get an explosion. Okay, how do you find it? We look at one location. Let's say facility. Okay, the facility name is not V, it just has V. That's all it has. So we don't know it in advance, but I'm telling you, this place has only V. It has a number of cases, which is N1, just one number of cases. And out of these, the number of deaths, D1. And the fatality ratio is D1. The fatality ratio is D1 over N1. Now, when we have VX, we have also VVX. So we have V and we have VVX. So maybe even most of the patients, 60% of the patients are only V, but the 40% that had V and VX, maybe they have 40% mortality. Suddenly we have 20% mortality in the overall population, because out of these 40, 20 died because of the VX. And out of the 60, 1 or less died because of the V. So this contributed, let's say 0. This contributed 20, and it's 20 over 100, 20%. So how would we know? Looking at the macro level, we go from the hospital and we just go to the bird's eye view. Not all places, even if there is a VX, many places would not have the effect because the timing would be wrong. So first, many places are going to behave completely V. They're going to have low fatality ratio, low number of deaths, and probably a low N1, because fewer people are going to come to the hospital because of pneumonia, because there is nothing in the community which causes this. Importantly, if we look at variations between facility, if these facilities have only V, let's say facility 1, 2, 3, only V in all of them, no VX, only V, then there's going to be minimal variation in the deaths. If 1 out of 100 died here, then about 1 out of 100 died here, and the same in the third place. Unless there's a specific external factor, but all other things being equal, the mortality rate is just going to be basic mortality rate in a hospital. Furthermore, healthcare workers would not be affected by this disease because they would have their own mortality rate, which is really low. Very few healthcare workers die during their job normally or during the course of their job, even though it does happen. So it won't be zero, won't be even close to zero. And when you have old doctors and old nurses and administrators and whatever it's called, healthcare workers still, they can die from a heart attack or whatever, even pneumonia, and it's unrelated, but they were infected, so they're V's. So maybe a few healthcare workers can die, but it would be within normal range. When V overlaps with a silent partner, Vx, we're going to have more cases because Vx causes more morbidity in the population. It's going to send more people to the hospital, which means that we're going to have a lot more deaths. So the number of cases is going to be larger. The number of deaths is going to be much larger. And the ratio, the case fatality ratio, when Vx is present is going to be much, much higher than that when only V is present. Since V and Vx need to overlap for the silent partner effect, we would see huge variation between facility and facility. For example, you can have two hospitals, one by chance got one VX, right? Just by chance, one person got VX, infected another one in the hospital, they both had V, they're in a V ward, now people are hysterical again, you start populating the V ward, you give this VX a chance to create a minor explosion, but still an explosion. In the other hospital, just by chance, in this guy there was only one VX, here there's 0, so here there's going to be very low case fatality ratio, here very high. This one seed was enough to change the outcome in these two hospital wards, into these two hospitals, even though they are geographically, they can be, within the same city. Another thing is, when you look over time, this hospital, which had a very high fatality ratio, let's say in March, V and Vx overlapped in March. Okay, so we had very high fatality ratio in March, and then V returned, but Vx didn't return. So V returned in August, didn't cause anything. Or conversely, there was no Vx initially, or Vx was out of season. So V came, nothing much happened. Then Vx started rising in August. V also started rising by chance. Okay, so let's move on. There's also a huge impact on healthcare workers if they are within the risk group. So let's say that this disease, it's a new strain of RSV. VX is a new strain of RSV. RSV attacks mostly babies and very old people. None of the healthcare workers are very, very old or babies. And so healthcare workers are not affected at all. Another option is that you have something like flu. Flu can attack young people, can attack people of all age. Let's say it attacks young and above 60. No, it doesn't attack young. It attacks only above 60. So some of the healthcare workers are above 60, not a lot of them. But some of them are, and they're going to be affected when there is VX. So in some facilities, you're going to have 5 healthcare workers dead. And in Milan, the vast majority, you will have 0. So you have like local explosions, which are difficult to understand. This hospital got fucked. Why? We don't know. This hospital got screwed. Why? We don't know. All these other hospitals did fine. So it's going to be rare because VX overlap is rare. So you need a VX overlap and an old or a healthcare worker in the danger health in the risk group. In SARS, for example, many, I think around 50% of the casualties were healthcare workers. It's a nasty virus for relatively young, healthy people. And that's a telltale sign of a novel virus. Now VX is that virus in this case, so it can cause it. But when it's not around, when only V is around, then you're looking only at V. Then you say, well, V doesn't kill healthcare workers in everywhere, but here it really killed a lot. So really dangerous for healthcare workers. Something to consider. They should be rare, silent partners, because most of the time you won't make this mistake. There must be okay. First, you need an unidentified virus VX, which is dangerous. So, like at least novel flu-like level, right? Doesn't have to be SARS, but at least has to be like significantly more dangerous than the seasonal variation. And that's rare. There is a note here at the bottom, but yeah, it's a note. If you want to read it, I think it's a good note. There's definitely a lot of known V's which cause milder disease than VX. If SARS is VX, or Spanish flu is VX, let's say, then there's a lot of viruses, V's, which cause a much milder version of that. For example, the regular flu, or adenoviruses, or a bunch of viruses can do that, right? And they're not that dangerous. But Spanish flu causes also these symptoms, but it becomes worse. So V is a tame version of VX. V and VX must coincide. We already said that. Now this is interesting. There must be some confusion regarding the disease caused by V. So there has to be some kind of a belief that V causes a more severe disease than it does. Now, I can't explain why something like this would happen, but mistakes are made. Right? You can, for example, misdiagnose V initially. So you have cases of VX, you find V in VX patients, because V is very common. So a bunch of people get sick, they lose eventually the VX, but V is also around, and by chance you found V and not VX. You looked actually for something new and you found V and not VX. And why would you not think it's V? It's in everyone who's sick. I didn't check a lot of people who are not sick, but I see it in everyone who's very sick, so it must be it. But maybe it's just really infectious. So there must be some confusion, and specifically, the severity should be overestimated. These are the conditions where the silent partner effect can take place. And the silent partner effect is can be nasty. I wrote a paper on this. This is me. I wrote a paper on this where I describe a very specific case of a silent partner, where a unique case, I would say, where the silent partner is a sub-viable virus. It means that it has an R0 which is smaller than 1, and it can still cause outbreaks when this policy is installed. So if there is a VX, and this VX is not even viable, right? It can sometimes infect 3 people, but most of the times it infects 0 people, so its average R0 is 0.8. Now, if you take these VX patients and crowd them with a bunch of susceptibles, then you have a chance of creating a local explosion. Now, this may not actually go beyond the facility, but it could be very deadly. But this is a completely different. Also here it's a super spreader and has to. VX is a super spreader type virus and it has a high pathogenicity and low pathogenicity forms, so it's a bit different. But it's kind of funny when you just reduce the density, and so this is the density 95. So when the density is very high, this red, even things with very low R0. In this case, RH value is very high, so 1 over R0, then they can thrive and cause major damage. And as you reduce the density, the number of patients crowded in a particular place together with these VX, this special VX thing, then you reduce the chances of an outbreak to essentially 0. Now we do this thing where it's going to be a sheep and it's going to have a mask. The etiquette dictates that if you like this video or found it interesting, then you would hit the like button. And if you have a question, you can ask in the comments, and I would be very happy to answer if I can. If you subscribe to this channel, then I will have more than 3 subscribers. That's about it. Thank you very much. Have a great